Welcome, everybody. We're going to go ahead and get started. Thank you for joining another meeting of the Nashville Modern Excel and Power BI User Group. So we're going to start out by going through a few announcements, and then we're going to show you what was new in the last release of Power BI Desktop, and then the Power Platform generally. And then Ben Gribaudo is going to share with us about how Power Query thinks. So we got a lot of good things in store. A few announcements. So if you're not worn out by this meeting, the Memphis Power BI User Group has a meetup tonight that's online that you could join. You don't have to drive to Memphis, and it's about Power BI adoption, and they're going to go through some practical tips about how to roll out the self-service and enterprise features in Power BI in your organization, and really think about your company's culture and how all the different roles people play in using the Power BI service. And so they're going to walk through some tools that Microsoft's put together with the community called the Power BI Adoption Framework. And I've looked at it. I haven't used it, but it's very solid material. And so they're going to go through that in their user group tonight, if you're not zoomed out by the time that happens. The Power Platform Microsoft team had a launch event that just happened 2 days ago. So it's on demand if you want to watch, but they do that. They do this quarterly to kind of review the things they've released over the past quarter. So that is something you can check out on demand. And again, since we're in this COVID scenario, we don't have a lot of, normally we would cover different in-person meetings, but since there's not much of that, and since this is a Power Query Day, I thought I would mention a podcast I listened to recently that was with Sid and Miguel on the Power Query team. And they've been on the team at Microsoft since the beginning. And I've always been fascinated by Power Query because when it came out, it had so many features. It looked like a tool that had been worked on for years, and it just showed up out of nowhere. And I was always interested in the origin of it. And I actually looked back, like I remember I talked about Power Query at our user group, and I went back on Meetup to see how long ago that was. But in 2014, I think it was the first talk I gave about Power Query. And part of it, I remember I investigated, where did this come from? And I asked a Microsoft employee, and he said that it had been, the language kind of was under development first, and then they developed the UI, and it was aimed at an enterprise modeler, like a data modeler versus a power user, Excel user, but they kind of pivoted. And that's what this Microsoft employee told me back then. And in this podcast, they kind of affirmed that was the case, that they kind of, the direction and the use of Power Query kind of shifted as they were working on it. So I thought it was pretty interesting, and just wanted to recommend that since we're going to be talking a lot about Power Query today. But it's raw data by P3, and you can look for their podcast, and I think it's maybe 3 down from the latest right now. And then we have some upcoming meetings that we're still trying to nail down the dates, and we don't have those posted yet, but we should shortly. So Alex Powers is going to talk about paginated reports in Power BI, which is a great way to deploy printable reports or reports you can export in many formats alongside your interactive dashboards in the service. And it's also great now that there's Power BI Premium per user, so more people can get access to this feature without being a premium enterprise. And then in June, we've got Steve Wexler. He's actually coming from the Tableau community, but he's generally a data visualization consultant. and he wrote a book on data visualization. And he's going to present some of the topics out of that book that are not tool specific. It's just more general data visualization principles. And that'll be in June. And we're working on the data, and we'll announce that soon. And then we have a lot of people that come to our group that are either they're looking to learn, they may be looking for jobs. And then we also have people who come who are employers. So we do want to help connect people, and that can be, we're not in person, so that's harder to do this. But if you do have any job opportunities that you want to share with the group, or if you're looking, if you want to put that into the chat, I can kind of summarize and highlight those later on in our meeting.
Hey, Will, can I jump in here for just a second?
Yeah, you can.
Thank you. So I maybe haven't told you this, but so I was recently promoted to the manager of management reporting at Exelis. So Exelis is a company that we make a web app for hospitals. And so we created this, we're growing like gangbusters. We've hired about 100 people in the last year or so. We're just growing by leaps and bounds. And so we are creating a new management reporting team, which right now consists of me, and there's one open position for a management reporting analyst too. So if that sounds like something that would be interesting to you guys, we're building the team from scratch, which means we're building all the reporting from scratch. So you'd have the opportunity to help build this team up from nothing. So if that sounds like something that would be interesting to you, hit me up in the chat, ping me on any of the platforms, email, LinkedIn, et cetera, et cetera. So yeah, get in touch with me if it sounds interesting.
That's great. Congratulations, Michael. I hadn't heard that.
Thank you.
So if you have something, just post it in the chat and I'll follow up later on either if you're looking or if you have an opportunity like Michael just shared. What's new? I'm going to turn it over to Teresa. Teresa, if you want to unmute yourself.
Sure.
Teresa is as you can read on the slide, a junior instructor in data analytics at the Nashville Software School. And I love the end part that you are a nerd and proud of it. So I thought I'd highlight that. And you see her contact info on the screen if you want to connect with her, but she's going to share with us what the new release of Power BI Desktop. So Teresa, if you want to share your screen.
Yeah, I can't share while you're sharing as well. Sorry.
Okay, I stopped. So if you want to go ahead.
Hey, everybody. It's good to be here with you today. There's a lot of new features in Power BI this month. And one of the ones that interested me was the new selection tools in the Azure Map visual in Power BI. So that's the one I'm gonna highlight today. One note, the Azure Map visual is still in preview. So if you haven't already done that, you'll need to go to the preview features and options to enable it. The data set that I chose to demonstrate these new features is the historical markers data from the Nashville Open Data Portal. I've worked with it before, so I had previously added categorization information that's not in the original data set. So to create an Azure map in Power BI is pretty simple. It's once you've added it, it's one of the basic ones. It's a stylized triangle that looks kind of like the communicator pin from Star Trek. I am a nerd, but I also had very, very nerdy parents. You do have to have latitude and longitude information for an Azure map. So that is one thing to note if you're going to use this, this map visual. So the new selection tools should be on by default if you've updated to this month's Power BI release. If it's not, you can enable them by selecting the format field or the section and toggling it on in the map selections right there. So now I've gone through that. I'm going to get rid of all this so the map will be a little bit bigger. So there are 4 selection tools included in this grouping. There's the radial or circle tool, the box, a polygon, as well as a range selection. So the radial and box tools work pretty much the same way. With the radial, you just drop your pin in the center of where you want by clicking, and then you click and drag to select a radius, drop it, and then the highlighting disappears, but the points within the circle remain active. With the box, you just click at the corner of the box that you want, drag it to the size that you want, and then again, same way as with the circle. With the polygon selector, you've got a couple of different ways that you can use this. You can either click and drag to draw an outline around an irregular area. Once you've drawn your outline, just double click, and same as with the other 2 points within the polygon remain active. You can also use the polygon to drop your corners and then define the area that's going to be within your polygon, like this. And then, of course, once you've completed your polygon, double click and the shading goes away. So with all 3 of those, the shading does go away, which I kind of hope they'll add an option for the shading to stay, because I would like to have that information persist. The last tool in this set is the range selection tool. So with this one, you just click on that. You have a pin that you can drop, anywhere within, kind of where you're starting from. So I'm just going to start there at the capital. And then you can select your travel either by time or by distance. So if you do time, let's say 5 minutes, you want to stick close, and you can decide whether you want to see the outline in the map or not with this one. You do a search, and eventually when my computer finishes thinking about it, you see the distance that you can travel within that 5-minute time frame from your starting point.
Is that driving or walking?
It says, I believe it's driving time.
Okay.
The box just says travel time, but I think it's driving. So yeah, good question. You can also do it by distance, and let's say you can choose kilometers, meters, miles, or yards. And you do that search. And again, that's, driving distance rather than just dropping a circle that's a mile around your starting point. So you can see how far you can drive from a certain starting point. I find this one useful. I mean, obviously, you want to see historical markers within a certain area, which is part of my interest. You can do this, but it would be useful in a business context to see what area could be covered by a particular store location or possibly a hospital. And it could also identify areas where maybe the business or there's not coverage. We might add more locations, or where there might be too much coverage and some inefficiencies there. So those are the new selection tools in Azure Maps. I hope you found that interesting, and thank you for the opportunity to share with you today.
Great, thanks so much, Teresa. That was fantastic. That exceeded my expectations of what the new features were. So that's really cool. Let me get back to sharing my screen. So again, there's Teresa's contact info if you want to message her. And then really quick, here's a few things that are new in the Power BI service. So this is the service and miscellaneous. So support for external tools in Power BI Desktop is generally available. So they added to the ribbon where third-party tools like Tabular Editor and DAX Studio and Excel can be connected to quickly. So that's super helpful if you haven't checked that out yet. But that is a part of Power BI Desktop now. in Power Query Online, they've been working on a diagram view that is, it's added to the Excel UI for editing data, but you can view it as more of a data flow. And it's similar to Alteryx. If you ever used that tool, it kind of looks like that to me. But it looks pretty cool, and I haven't used it yet, but I'm excited to see where that's going. And they also stated that they're really focused on data flow, which is Power Query Online. It's just a different name for it. Performance and reliability. So they're just trying to make it faster and more usable. That's kind of a focus of the team right now. So I'm excited to hear that. There was a lot of detail behind that, but that's kind of the summary. And then Power BI Premium per user is available to purchase, and it is $20 per user per month. So I don't know about you, but I was expecting it to be around the $40 mark. So I was pleased when I heard that it was 20. So I feel like that's a good price, and hope to be using it soon. And then there were a lot of enterprise BI features like scalability, object level security, that I'll just leave you to the blog to check out. But there was a lot of detail there as well. And then in the Powerapps world, one of the big announcements was that they're taking the formula language called PowerFX out of Powerapps, and they're generalizing it and making it so you could apply it to other tools. So they made it open source, but they also are going to try to apply it to Power Automate and Power Virtual Agents and Dataverse. So you'll have this one formula language that's similar to Excel, where you can express your logic in these different Power Platform tools. They also made mixed reality components generally available. So that's where you can create a mobile app that overlays something on the video of your camera, so you could view something in your space, for example. There's so many things you could do with that, but that is generally available. They added printing to Powerapps, so there's a function for printing, and there was logic in there, like I have the if screen.printing. You could specify what behavior the app would do. So for example, if you print the screen but you don't want the buttons to be printed, you could have them hide for printing with that logic. So that's a nice feature. And then the enhanced formula bar is generally available. I wish I had a quick demo for you guys, but I love the Powerapps formula bar. It's very usable. Like you can hit enter, you can hit tab, and it just does what a text editor would do. And another cool thing is you can highlight a portion of the formula, and it will preview under the formula bar what the results would be, whether it be a scalar value or a table. And I think that Power BI has a lot to learn from this formula bar. I wish you could just highlight a part of DAX and it would preview it there, whether it's a table or not in Power BI. So that it used to be a preview feature. Now it's whatever if you use Powerapps, it's the production version now. I like the guy who wrote the blog. He's not very corporate. He kind of just very frankly tells you what they're doing. And he said in his blog post, our goal, one formula bar across all products. And so I thought that was great to hear. He did caveat that to say he meant that with respect to Powerapps, Power Automate, Power Virtual Agents, and the Dataverse. He said they're not going to touch M or DAX because those are they do different things. And I thought that was a helpful distinction. He said PowerFX is it's a formula language that's for small data where you're reading and writing and you're doing it against a relational database, whereas M is made for the messiness of connecting to any data anywhere and transforming it, and DAX is about slicing and dicing big data. And so he said those, of course, will remain. They're doing different things, so they're they're going to be their own language. But Power Effects will, as far as the other Power tools, will be the one formula bar and the one language. So I thought that was helpful to hear the direction they want to go. And then Power Automate, desktop flow queues is generally available. So what this means is you have a computer that's kind of acting like your robot, and it's doing different automated UI tasks like entering data into an old application, or getting data from a website and putting it into another website, or doing different file processing that's manual. So you can imagine if you had this computer set up and you're sending all these tasks to it, that if you send two at the same time, it's going to be in trouble. So there's a queue now where it will queue up all those tasks that get sent. And you can actually send the priority. So you could send a task and make it a high priority, and then it will move it up in the queue. So your one computer can handle multiple desktop flows at once. So I thought that was a needed feature. And then there were also some AI builder updates related to reading information off driver's licenses in different forms. And you can go to the blog to get the details. I haven't used AI builder, so I can't really speak much to it. But that's kind of a quick summary of the rest of the Power Platform and what was new in the past month. And I'm going to now turn it over to Ben to tell us about how Power Query thinks. And to introduce Ben, I can't remember, Ben, if I read your blog first or if Brent introduced us first, but either way, I think Ben's got the best blog out there for if you want to learn the Power Query language. As far as I know, the content out there, there's some videos by Chris Webb, and there's this really hard to read document that talks about the language. And so Ben's blog is the perfect balance where it's not too technical, but he does get into it and talks about the language. He answers all the questions you would want to know about how it works. And Ben is also, I shared with him some my M library, and he had some really great constructive feedback. So I can tell he's several levels ahead of me, and I think we can learn a lot from him. So thanks for joining us today, Ben.
Thank you, Will. Hello, Nashville. Thank you all for having me. Let's just get the presentation sharing here and we'll get underway. So, how Power Query thinks. How does Power Query's mashup engine process the expressions you write? Query folding is one key concept where behind the scenes, the engine may transform part or all of your M code into the data source's native query language, then ask the source to execute that query. Streaming, though perhaps a less familiar term, is even more fundamental as it describes how table, list, and binary data flow between functions in M. Let's take the mystery out of these two terms. But before we get to them, we'll lay a foundation of basic concepts about how the Power Query language works. Altogether, the goal of our time together is to give you an understanding of how Power Query thinks so you can write more efficient mashups, are better positioned to debug problems, and can avoid unexpected variability in results. Let's get going. Foundational concept number one. Power Query is partially lazy. In the let expression we have here on the screen, which variables values will be computed? Well, to figure that out, let's start with the result clause, that bit of code after the M. We see that variable A is referenced. So we know that A's expression, which says call service A, will be processed, will be executed. But nothing in here requires the value of B. Since M is partially lazy, it's not going to bother to call service B. M is partially lazy. The same applies to records. Here's a record. Looks kind of similar to the let expression we had a moment ago. We can see that the result clause in the let expression references the records field A. Since B isn't needed by that result clause, it's not referenced directly by the result clause, and it's not needed by something in what the result clause references. B is not going to be evaluated. M is partially lazy. Now, as an aside, let's refactor this expression. We're using a let statement here to assign the record a variable name. But we could get rid of that let expression in the variable name and just have the record and access the field of interest off it. This refactored expression looks extremely similar to the let expression we started with. Well, not only are these two extremely similar, but for practical purposes, they're identical. Because you see with M, a let expression is syntactical sugar for an implicit record expression. That is, the expression on the left is just basically a shortcut for writing what you see on the right, which means that what we know about how let expressions work also by definition applies to records, because a let expression basically is a record. So keep that in mind as we keep going on, that if you learn something about how a let expression works, it applies to records. And if you learn something about how records work, well, it just might apply to a let expression. Let, syntactical sugar for an implicit record expression. Now back to this idea of M being partially lazy. Notice the word partially, which implies that it's not always lazy. The principal exception, one of the principal exceptions to its laziness, are function arguments. Here we have a let expression, and we know that to figure out what M is going to do with a let expression, we start with the result clause, right? So down there, we see that after the M, the function do something is invoked. And since function arguments are evaluated eagerly before do something can be executed, the values for both A and B are computed. If you look at the definition for function do something, let's see, it's got an if then else statement in there. And only the value of A or B is ever needed. They're never both needed simultaneously. So since M is eagerly computing, eagerly evaluating the values of function argument, we're computing both A and B, even though we only need one or the other. So we're calling service A and B when we arguably only need to call one or the other of those services. What if we wanted to not do this extra work? Is there a way we could rework this expression to make it act almost as though it were eagerly evaluated? Though the function arguments were eagerly evaluated. Well, there is. Let's just change where function execution takes place. What have we done? Well, instead of assigning A and B to the result produced by executing call service A and call service B respectively, we save that execution to inside the then and the else clauses and do something. So when the result clause for this let expression, the bit of code after M is executed, do something is going to be invoked. The function arguments for do something are eagerly evaluated. But now that just basically means that just enough is computed to set them to be references to functions call service A and call service B, but those functions are not invoked because the parentheses are no longer there in the expressions defining variables A and B. So we pass in references to do something to both A and B do something's if statement, decides whether the then or the else should apply, and then and only then is the one function of interest invoked. So even though M is partially lazy, function arguments are eagerly evaluated. If that's a problem, or I should say if that's not the desired behavior, there's ways to work around it. M is also immutable. The code here is not Power Query. It's some made up pseudocode, but let's look at what it does to illustrate the opposite of immutable. We see that we have a variable X, we declare it, we set it to the value produced by calling service A, then we add 3 to it, and then we look at its value, and depending on what that value is, we reassign X to be either 5 or 2. This is not Power Query. It can't be Power Query because with Power Query, you can't change the value of a variable once it's set. Because in Power Query, variables are immutable. And since a variable in Power Query behind the scenes is the equivalent of a record field in Power Query, record fields are immutable. Here's a let expression. Question, let's think about this. How many times is the function call service A invoked? Well, let's see. In the result clause, we're building up a list. That list references variable A twice, once when defining its first element and once when defining its second element. But remember immutability. The first time variable A's value is needed, call service A is invoked and its value is returned. But it is also saved and set as the value of that variable. So the second time A's value is needed, that saved value is returned. So here, in this expression, even though A is referenced twice, the expression call service A is only executed once. Similar behavior holds true if call service A returned an error. That error would be saved into variable A, and then each time variable A would be accessed, that error would be re-raised. So in either case, whether call service A returns successful result or raises an error, that function's only invoked once and its result is saved. Now, what if we, for some unusual reason, didn't like this behavior? If we wanted call service A to be invoked twice when building this list, could we do that? Well, sure. What makes it only called once? It's the immutability of variables and record fields. If we don't save its value into a variable or record field, we sidestep the immutability, and you can see that below. We got rid of the whole let expression altogether. We just have an expression that defines a 2-element list. The first element is defined by calling service A. The second element is defined by, again, calling service A and multiplying it. M is immutable.
Ben, can I ask a quick question on that topic?
Yes, go for it.
How does table.buffer, where you, I imagine that's used to kind of save the results for use later on. Is that needed with immutability?
That is a great segue to what we're about to come into, because you notice by immutable, there is an asterisk. What we've just talked about holds true across the board, but there's more going on than what we've talked about. And so to kind of build up to what you just asked, Will, let's look at this let expression here. So based on what we know, which is true, that in Power Query, variables are immutable. Let's try to make a guess as to how this expression will be processed by Power Query. All right, so we know from what we've covered already that the language is lazy. So to figure out what needs to be done to execute a let expression, start with the result clause. So the result clause, again, is the bit after that in state. Here it's the statement is just first 3, so it's a variable reference. So now we go up and find first 3. It's a table first in function call. It's passed an argument. The first argument is filtered. Arguments are eagerly evaluated. So let's jump and figure out what would be passed into filtered. So filtered, oh, it's another function called to table select rows. Its first argument is source. Function arguments are eagerly evaluated. So what's the value of source? Well, let's see, source is a call to get data. So based on what we know so far, it would seem like this is going to be executed by get data running. And then the data it returns being saved into the variable source. And then that variable, that data set, being passed to table select rows, that function running, and the entire data set it returns being saved into variable filtered. Then that data set's passed to table first in, it runs. The output of that is saved into variable first 3 and returned to the client. Let's call this the simplistic approach. This is not how Power Query works. To visualize it though, and to help us think about why it's a good thing Power Query doesn't work this way, let's try to visualize how our simplistic approach works behind the scenes. So we would be saying that with the simplistic approach, the first step is to get all the rows from source, save them to variable, and hand that data set to table select rows, which does its thing, save its result to filtered, hand that data set to table first in, which does its thing, hands its rows to save its rows into variable first 3 and returns those to the host application. Again, this would work. It's theoretically sound, but it has some downsides. Let's think of what those downsides are. Well, first downside, we need at most 3 rows. But that's not communicated back to the left here. What if the first 3 rows from source are the rows that will all pass the filter and satisfy first 3's request for 3 rows? So all we really need will be 3 rows here. There's no communication of that information back along the chain here. We have to pull, or our hypothetical Power Query engine would have to pull all the rows from source, even though maybe we only need the first 3 of them or the first small portion of them. There's one downside. We might be doing a whole lot more work than needed with this approach. Another downside, we have to have local resources to store all of the rows from our source. What if source contains millions, billions, or even trillions of rows? Now, again, we only need 3 of them ultimately, but we've got to have disk or memory, something local where we can persist temporarily all those rows in source, which means that our local systems resources, or the Power BI service or some cloud, some cloud service somewhere, resources could be quite taxed by an expression we write and would limit the quantity of data we can, not the quantity of data we can output, but the quantity of data that can be in our input. Thankfully, this is not how Power Query works. The foundation for how Power Query handles tabular data, as well as list and binary data, is called streaming. Now, with streaming, what's saved into each of the variables is immutable, but it is not the actual data. It's rather an immutable handle or promise or iterator that, when invoked, will produce the requested data. So first 3 is going to hold this iterator, and once it's saved there, it can't be changed, but it can be invoked many times, and only when it's invoked does it produce data. Filtered is also going to be set to be another promise or iterator. When it's invoked, does whatever it needs to do to produce the filtered data, and the same for source. To make a little sense out of this, let's walk through how it works. So the request comes into first three from the host application to produce a row. You notice I said a row because with streaming, rows move between steps one at a time. So the request comes in for a row. First three, which is going to evaluate a function call to table first in. With its first argument being the variable filtered, it's going to start running that function call. It's going to turn around and call the handle it holds to filter and say, may I have a row, please? Filtered's going, let's see, it's a call to table select rows. With its first argument being a immutable handle to source, it's going to pick that handle up or that iterator and say, I need a row, please. Source is going to do whatever it needs to do to get a row. And it's going to stream it to filtered. Filtered looks at that row, looks at its test criteria and says, hey, yes, this passes the filter. It hands it to first three. First three says, here's the row you asked for. The requester says, all right, thank you, may I have another row, please? And the cycle repeats. The request for another row, the enumeration of the iterator, if you would, travels from first three to filtered. Filtered turns around and asks source for another row using the handle it has. It hands it to filtered, but this time that row did not pass the conditional check that's in the table select rows expression that makes it filtered. But filtered, oh wait, I've still got an outstanding request for a row, so it turns around and it asks for another row from source. Source streams that row to filtered. Thankfully, this one passes the test. It flows out to first three hands it off to the host application. And this cycle of the request flowing down to the source and then the rows being streamed one at a time through the steps and on out to the requester repeats until either 3 rows have been returned or until no more rows are available. So with this, as soon as 3 rows are returned, execution stops. Well, the host application can ask for another row and then first 3 is going to say, hey, I have no more rows to give you because it knows it's already returned 3 rows. And so execution stops. So with this, one beauty is we stop work as soon as we've done enough. We don't have to pull all the rows from source if the first 3 or the first 50 or whatever are enough to satisfy the output we're requesting. We also reduce the amount of data that needs to be buffered. We're not pulling all rows from source and saving them into a variable. Now, let's be clear though. With streaming, rows flow between steps one at a time. That doesn't mean a step internally is prevented from choosing to work with more than one row at once. Source is a good example of this. Let's say the source here would be a web-based API. Well, typically when you call a web API, a data connector is going to fetch a whole page of rows. So what would happen here is that the first time source is asked for a row, it does whatever it needs to do to get its first page of rows. It internally buffers that. And then streams the first row out in response to the request it received. The next time source is asked for a row, it can read the second row out of the buffer and so on as it goes, as requests come in and it works through its buffer. Of course, once it's read all the way through the buffer and the next request comes in, then it turns around and gets a new page of rows and streams the first row of that page out. So again, the key here is with streaming, rows flow between function calls, one row at a time. We avoid or minimize, reduce the downsides of the simplistic approach, but that doesn't mean that a given function might not internally buffer. So jumping back to the expression we saw a moment ago, the 3 variables are still immutable, but what's stored immutably in them And each of them is a handle that can be invoked to produce the requested data, not the data, not all the rows themselves. With streaming, order matters. So here's a expression or I should say the steps from an expression. So the host application is going to start by asking filtered for a row. Filtered is going to turn around and ask sort for a row. And sort's going to turn around and ask source for, well, one row or, but in order to sort, unless there's somehow knowledge communicated that source is already sorted, sort actually has to do the sorting, right? Which means that sort is going to need to pull all the rows from source, buffer them locally, sort them, and then return the first row to filtered. When a request comes in to filter from the host application for the second row, it's going to turn around and ask step sort for its second row, and sort's just going to stream it out of its buffer and so forth. But this is still better than the simplistic approach we started with, because with the simplistic approach, every step is saving all of its results into a variable. Here, only the function calls that need to buffer data. But I said order matters. What do I mean by that? Well, here are the same 3 steps, just in a different order. Now, a sort and a filter can be swapped and still produce the same result. But notice the difference in efficiency between these 2 orderings of steps. On the right, the host application is going to ask sort for a row. Sort's going to turn around, and it still needs to do its sorting. So it's going to ask filtered for a row, and another row, and another row, and another row. But now the sort step is buffering filtered rows. So let's say source is returning 1 billion rows and only 500 pass the filter. With the order of steps on the right, only 500 rows are stored in sort's buffer and sorted. Whereas on the left, all billion rows have to be stored in step number 2 in sort's buffer. So with streaming, order matters. Here's a gotcha to be aware of with streaming, and that's restreaming or multiple iteration. In this expression, we are referencing source twice. Now, we know that source itself is immutable, the expression in there, but it's just a promise or an iterator. So when the first list sum runs, it's going to enumerate the data in source to compute its sum. And when the second list sum runs, it also needs to enumerate the data in source to compute its sum. And perhaps surprisingly, those 2 enumerations could produce different results. These 2 sums, which it seems intuitively like they should be identical, might not be identical. You say, well, how could that be? Well, what if the data source changed between those 2 enumerations? Since the data source has been enumerated twice, that change could be reflected in one sum, but not the other. Now you'll say, wait a minute though, but why would I write an expression like this? If I want it to sum something twice, I mean, that doesn't make sense. Well, you probably wouldn't, I agree with you, but we might write expressions that do something like this behind the scenes. What if you want it to compute a sum, and instead that second list sum was actually list average? Well, to compute an average behind the scenes, in essence, you're computing a sum, right? So behind the scenes, something like this might happen. So something to be aware of, that with restreaming, or with streaming, multiple iteration can bite you. Well, what can we do about it? Well, in a simplistic example like this, you could just have computed the sum once and saved it to a variable. But for a more general solution, well, here's table buffer for you. We can use our buffer. And so what we're doing here with a buffer, let's think of how this works. So the result clause, the in statement, the first reference list sum is going to try to enumerate buffered. When buffered is asked for data, what's it going to do? Well, it's going to get that data from source and then, well, buffer it. And other code that references the same buffer will then, of course, read out of that buffer. So this gives us that stability. It lets us avoid that multiple iteration situation that we've been talking about, albeit at the cost that we now have to have local resources to do the buffering. So this puts us in control of if there is a point where it's to our advantage to get all the rows from the previous step, whatever that might be. In this case, it's sources get data, and persist it temporarily locally. Then we can do that with a buffer. Now, again, here's our expression we've been looking at a few moments ago. We're all happy it streamed. It's much better than the simplistic approach. Until the resident SQL expert says, but guys, you still are moving a lot of data here, potentially. What if we have to pull 100,000 rows to find the first 3 that match code 50? You're still streaming a lot of data. If I just wrote a SQL query, I could tell the database server exactly what we wanted. It has things called indexes, and it uses things like memory pages to handle this kind of stuff extremely efficiently. And it would, with the query tailored just to this, it would send just the 3 rows we need across the wire. A lot less data moving. We are pushing the request right to the source, just much more efficient that way. Turns out that sometimes Power Query can help us out here. You see, you could be wondering if what I'm really saying is we should just write SQL by hand and not really use the beauty of Power Query steps. And that would be a real bummer if that were the case. But thanks to query folding and Power Query, it sometimes will do that work for us. That is, when the Power Query engine sees an expression like the one on the left, depending on the version of the mashup engine you're using, and the data connector you're using, and the particular data source you're talking to, the engine and data connector may work together to translate what's on the left to approximately the equivalent of what's on the right. So here, you wrote what's on the left using the functional, expressive Power Query language. But what gets executed is a very efficient native query that is hopefully achieving the exact same effect. Now, we'll talk a bit about this, but one point to be aware of, when we push execution from one system to another, there sometimes can be subtle changes that impact that execution. And Will was mentioning an example of one before we started here. Let's say that filtered expression there, where we say each code equals 50, let's say that we were comparing to a string instead. So we said each code equals quote ABC end quote. Well, in Power Query, at least if you're on an US English culture system, that's going to be a case-sensitive comparison. Whereas in SQL, let's say where code equals quote ABC end quote, that might be a case-insensitive comparison depending on the column collation in the database. So just a point to be aware of. Power Query's query folding will translate equivalent function calls to equivalent native code, but that native code might not be quite as equivalent as you hope in certain nuanced cases due to culture type and similar nuanced behaviors. All right, so this is query folding. Again, we have us a set of expression steps here. The first two are foldable, the last two are not foldable. So execution, let's see, how's it going to work? Well, Power Query, the mashup engine, is going to fold the first two together. So the expression you wrote with 4 steps, where the result clause is referencing the fourth and the fourth is referencing the third and so on back to 1, in essence becomes, you know, a 3-step expression where the folded expression gets, you know, wires up what's necessary to have the external source natively process those steps. And then data stream from there through the remaining steps. Which, by the way, let's just keep in mind when we say, when we talk about query folding, I like to think of it not as streaming or query folding, but as streaming or streaming plus query folding, because streaming is still at play even when query folding is here with the steps that can't be folded. Right. Now, order matters also with query folding. By the way, you can see here that if we, well, here's a great example. Here we have 4 steps. The first 2 can be folded together. That third one, though, blocks the fourth one from being folded up with the first 2. Now, if you knew this, you could reorder them by hand and make it, if that was acceptable in your circumstances, if that didn't change the results of your expression. But sometimes the mashup engine helps us out here. If it sees that steps 3 and 4 here can be safely inverted without changing the meaning, without changing the data returned, it might actually rewrite them for us behind the scenes, reorder things for us behind the scenes, so that way it can achieve optimal folding. Now again, if you can put things in the proper order, that's great. This is just a nice safety net that sometimes helps us, but I'd encourage you to think about order when you write your expressions. Order matters, but sometimes IM helps you out. And as an interesting aside, this optimization phase can run even when there's no folding or data source. So if you write an expression that doesn't even touch a data source, but IM sees that certain steps could be more efficiently ordered differently or even eliminated, it just might do that for you. But it's only going to do that if it is confident that its optimization is not going to change the actual results being produced.
Ben, is that optimization a newer thing, or has that always been there from the beginning?
I don't know when it was added, but it's not a brand new thing, I'd say that.
Okay.
Great question. Now we come to one of those, another, I should say, of those Power Query things that may seem mysterious. Those privacy level settings, which relate to the data protection firewall. Let's examine this let expression. The in clause here references filtered. Filtered, what's filtered doing? Why, it's table select rows. And in order to execute select rows here, we need to pull data from source A and source B is involved. Let's see here. So we're taking the rows from A and we're looking at A's ID column and we're checking whether B's filter ID values, whether the A ID value is contained in the list of B filter ID values. So query folding, as we've discussed thus far, or as we've described it thus far, doesn't help us here because we're crossing data sources. Now, thankfully, this is not a showstopper. For one, IM can still use streaming to pull this off. But that might not be the most efficient way to pull this off, because what if A contains billions of rows and B has only 4 IDs? We could stream all of A's rows, filter them to B. Now, if we were doing this in SQL, we would maybe write something like the SQL statement on the left. Select from A, where ID, and we just put the 4 values we wanted there. Turns out, thanks to query folding, IM might do this automatically for you. That is, when it executes the expression on the right, it might decide to write a native query for source A, or it might postpone sending the query to source A until it's pulled values from B, and then it can take those values and write them into the query sent to A. So it could produce a native query equivalent to what we see on the left, which can be tremendously helpful for performance purposes, because now we're not streaming all rows from A, we're pushing the filter into A. This can also be dangerous. What if B is some highly proprietary, perhaps even legally protected information, and A is a public data source run by one of your competitors? You, in that case, probably do not want to and should not be taking data from B and writing it into A. The sole purpose of the data protection firewall and those privacy level settings is to control when data between sources can be combined like this. So that those privacy level settings, the data protection firewall, aren't there to keep an expression like the one on the right from being executed. They're there to control how IM executes it. Because we've already covered, we could stream the expression, just use streaming on the right, and it would work fine. Just may not perform as well as we want. So those privacy levels, they're there to help with, they're there to control query folding between data sources. We talked a lot about query folding. And you can imagine that it's generally advantageous to use query folding or to have it occur if it can occur. So how do you know when it's occurring? In Query Editor, you can right-click on a step, and there is a View Native Query option. If that option is not grayed out, then you know that query folding is occurring. If that option is grayed out, as it is here, you don't know whether query folding is occurring. Why is that? Well, one reason is that Query Editor may not be able to follow the behind the scenes optimizations that Power Query applies or may apply to an expression. So in this expression here, the steps in red, the last step there was combined with the first two, I'm sorry, and they were folded together, but the UI doesn't know this. So it doesn't know how to associate the fourth step, to get the native query for the fourth step. So even though query folding is happening, the UI is not telling us that here. Another reason why the view native query option can be grayed out is that it's only supported for certain data sources. So unfortunately, in Query Editor, there is not a good way to authoritatively know when query folding is happening. You may have to resort to doing some query diagnostics to get the native query being used, or to even hop over to the external system and run a trace of some sort to see the native query being used and look at whether it looks like any of your steps have been folded into the native query. This is an area that I very much hope will improve in the Power Query world. There is some effort being done on this right now. In Power Query Online, you may have noticed that steps now have an icon that can appear next to them to reveal what's going on with query folding. I think that is a very helpful step in the right direction. Because remember how we said that order matters with query folding? Well, what happens if you have this expression, you've got the steps in the right order, it's optimal for what you want, query folding's happening where you want, you verified that by checking the native query, and then down the road, you add a new step somewhere in the middle. Well, did that break your query folding? And greatly reduce where it's occurring? Well, you can do the work to go check the native query and all again. Or it would be nice if there could just be a little icon by the step telling you if it's being folded or not. And that's something they're working on right now. So to me, that's exciting. So as we wrap up here, we've talked about query folding, we've talked about streaming. And a key concept has been that order matters. And let's talk about that a little more before we leave the topic. So probably the ideal order is to have the steps that are query folded together come first. So that way, as much processing as is practical is deferred or delegated, might be a better word, to the external system, the actual data source. And then after those foldable steps, of course, streaming is going to take place for table data. To order the steps next that don't internally need buffering, put your filter before your sort, that sort of thing. And then lastly, if you can do it in this order, put the steps that would need to buffer last, so that they're only buffering the minimal amount of data needed. No, maybe that's not going to matter if you're working with a small amount of data. So, keep in mind the size of data you're working with as you apply this thought. It's general guideline. It's not a hard and fast rule. But it leads to a question. You say, well, how do I know which steps query fold? And how do I know which steps that are streamed will buffer? I would love to point you to some documentation that details this. But to my knowledge, there isn't any. On which steps buffer when streaming takes place, though you can perhaps deduce that by just thinking about how a step would work. A filter step, for example, doesn't have an intrinsic need to buffer data. It can look at one row at a time. The same with, that would be like table select rows. Or, tables add columns, same thing. It can add a column on each row as it goes by. Whereas a sort or a global group by, well, by definition, they both involve some kind of buffering. So unfortunately, while there's not a hard and fast list to go look at on which steps will buffer internally, we may be able to kind of figure that out by just thinking about how those function calls work. And it's also tricky to figure out which steps query fold, because that depends on quite a number of different things: the particular version of Power Query, the mashup engine you have, the particular data source, and the data connector version. So it's both an art and a science for optimization here. I hope, though, that this has helped to take some of the mystery out of the terms query folding and streaming, and maybe also to give a foundation for some of those fundamentals about how Power Query works, like its immutability and its laziness.
Yeah, this is very helpful, Ben. I think you've illustrated about how much thought went into this tool before we even saw it in the real world. They were probably working on it for years, given how much engineering is behind it. It's impressive.
It is quite impressive. I'm curious how long that development process took before it saw the light of day, the public light of day.
Yeah, I don't know. I listened to that podcast. They didn't say the number of years. They just mentioned that it had a long history before. So, and it was, I mean, the Microsoft research team had a hand in it, but so, yeah, I don't know. I'd love to know. But it was certainly a long time, because they thought through lots of different, like what you talked about: folding, streaming, ordering, immutability. How can we make this as efficient as possible? Do the least work.
One thing I find interesting about all that, though, is part of it is the language and part of it is the engine behind the language.
Yeah.
Like, you could take the language specification and implement it yourself, and you wouldn't have to do any query folding whatsoever. It just wouldn't be nearly as efficient, So, they've had to figure this out at multiple levels on how to pull off and do what they've done and done well.
Yeah. Yeah, that is super interesting. And then the optimizations that have gone into the engine to switch your steps around to make it more efficient on the fly. That's pretty cool.
And they've got to get that right too. If Power Query is mysteriously changing your results behind the scenes, you're not going to use it.
Yeah, that's right.
How to deduce which steps they can reorder safely and which ones they can't. Yeah,
that's right. And I've always known it to be accurate, and that's what we need. We need to trust it. Does anyone have questions for Ben? I have a few, but if anyone else would like to go first, you're welcome. You can unmute yourself. Ben, I had two questions around, I guess when you're working with bigger data sizes, what are some of your tricks to get around the pain points? And then the other one is, have you used any of the performance diagnostics and found those helpful? I haven't used those myself.
I have, on the latter, I played with them. I haven't really had to use them since they came out. I haven't had a deep performance issue to debug, but I have played with them before and after they were released, and it is, I guess, more before they were released. And I think it's a neat step. It's a lot of data, though. It's more of I think of it more of as a toolkit versus direct, how would I say it? You have to spend time making sense out of the data. It's like looking at a log file, right? It's not going to say, here is the problem, fix it. It's going to say, oh, here's a bunch of metrics. You may find a lot of gold in here, but you got to dig for it. So it will be neat to see as the community comes up with ways to work with that. It'd be neat to have a template query you could throw on top of that and have it just highlight the top 5 slow performers or whatever. That kind of stuff.
Yep, totally. And what about the big data sizes? Any?
Are there particular pain points that are jumping to mind?
I just think, I mean, I've seen several users that just get stuck using Power Query when the data sizes get big, and they're like running out of memory. Their laptop can't handle what they're trying to do. That it is a pain point for people. Of course, when you know how Power Query thinks, that helps. So just what we've talked about alone could help you solve the issue. But I didn't know if there was anything on top of that that you would add.
Well, I'd be thinking about, why am I running out of memory? You know, if things are streaming one step at a time, if things are flowing between functions one step at a time, if my memory is getting consumed, then maybe, quite likely, it's because one of those steps has to internally buffer. Because in theory, I could sit here and stream an infinite number of rows without it really changing my memory utilization if nothing was getting buffered and I was just throwing them away. That's the part of beauty of this kind of pipeline based approach. It's not a unique approach to Power Query. There's other data processing things that do it that way. So if I'm running out to memory, am I doing a sort, a group by, something in there? Or, you know, if it's just a performance issue too, am I doing something? Maybe I'm doing a comparison between, like, a list contains, let's say, between one data source and another. And for some reason, it's not able to optimize that. And so for every row in the one list, it's pulling all the data from the other source to check against that row. I mean, I think Chris Webb had an article some time ago where he was comparing performance. Basically, it was like reading a small amount of data from an Excel sheet, and it seemed like it was getting read like many times. And it was because of the join algorithm that Power Query was using, if I recall right, where it would read one row from the left side and then read all the rows from the right side to look for the matching row or rows, and then read the next row and reread. And so there, you know, you in essence needed to do something to get it to use the right join algorithm in that case. So it's quite possible that the big data pain is just an optimization challenge.
Yeah.
Though one point on optimization, I think there is a misconception to be aware of as far as for the lifespan of buffers. A buffer lasts for the current execution of a query only. So if I have query A that does some things and then pulls data from query base, and I have query B that does some things on its own and also references query base, there's no sharing of buffers between query A plus base and query B plus base.
Oh, I didn't realize that.
There's separate executions. In fact, you can really think of them as query A, just query base's logic being written into query A. It's just kind of an organizational thing that you split it into two queries. Now, where you do get, it's not buffering, would be like with data flows. You can certainly do something in data flow and save the results somewhere, the base results, and then read them in multiple places. But again, that's not within the same query execution. Now, sometimes though, with data, the Power Query environment will help you out with the performance optimization we didn't mention, and that is, for certain data sources, the environment itself will buffer what's pulled from the source based on the native query. So if you run select A, B, and C from my table, and you run that multiple in your Power Query expression results in that native query being run multiple times, it's possible that the host, the Power Query environment will actually have buffered those results and restream them. Sorry, not restream them, but reuse that buffer, which just another aside on performance. And so that's where, like, under your Power BI settings, you have that like query cache. I forget what it's called, something like query cache. That's what that is.
Okay, got it.
It's used for that. But no, yeah. So, but jumping back to the question, yeah, it sounds to me like something in there is storing more rows locally than you're expecting.
Yep.
And this is where I hope we can see diagnostic tools grow. Like it would be neat to be able to run an expression, and then when it's done, have little kind of like pop-ups appear over your steps showing you where the memory usage happened on them. Or like, oh, this step, why it's got 12 billion rows buffered internally. I think I'm going to work on optimizing that one.
Yeah, totally. Like I could see in the step list, there could be the number of seconds it took to execute, the number of megabytes it used.
Yeah,
That'd be
exactly.
really helpful. Yeah,
exactly. Because
and I wonder if they're working on things like that. I know they're working on usability, and I think some of that would help it be more usable for beginners.
I hope so. I don't know, but I know I've mentioned something like that.
Nice.
Yeah. So yeah, mention it too. Again, they got the challenge of they're trying to serve everyone from beginners doing a little bit of data to people pulling huge amounts of data, and they've got to prioritize on where to do it,
Yeah, totally. Well, thank you so much, Ben.
Absolutely.
I'm going to stop the recording real quick.